So let's see the eighth one. Two balls x and y are moving towards each other with the speeds of 5 meters per second and 15 meters per second respectively. They make a perfectly elastic head-on collision and ball y moves to the right with a speed of 7 meters per second. What is the speed and direction of the ball x after collision? So to do this, you need to know that the relative velocity before collision is equal to relative velocity after collision. So what is the relative velocity before collision? This is a 5 meters per second towards right and then 15 meters per second towards left, which means the velocities will be added. That's the 20 meters per second. Alright, and the after collision, according to the question, the y is moving 7 meters per second to the left. So with what speed should it move to make the relative velocity same as before? So it has two options. One is it has to move in the forward direction with the 27 meters per second, and then in the opposite direction 13 meters per second. Okay, so the opposite direction 13 meters per second will be moving, and then that will be the resultant relative velocity 20 meters per second. That makes, so the x is 13 meters per second to the left, 13 meters per second to the left. Sorry, B is the right answer, like that. And let's see the ninth one. In the absence of air resistance, a ball thrown horizontally from a tower with velocity v will land after time t seconds. So basically there is a tower and then there is a ground, and then the ball is thrown with velocity v, and then it will fall the ground after t seconds. That's the question. Right. So if, however, air resistance is taken into account, which statement is correct? The ball lands with a horizontal velocity less than v after more than t seconds. Makes more sense, la? Why? Because if the air resistance is there, it will take longer, like the air opposes the motion of the ball, so the velocity decreases because it has to overcome the air resistance. So velocity decreases, which means less velocity, and then when the velocity is decreasing, of course it takes longer, so also the air resistance pushes it up. So air resistance is from all directions, right? So it wants to come down, but the air resistance does not let it come so soon. So what happens? The time also, it takes longer to come. So that is, it comes after more than t seconds. So the option is A, without reading the other options also, but you can read if you want. The ball lands with a horizontal velocity less than v after t seconds. So the time is not changed, which is wrong. The ball lands with the horizontal velocity v after more than time t, so the velocity did not change, wrong. The ball lands with the velocity v after t, so nothing is changed, wrong. So that's the options. Okay, and then let's see the 10th one. The two balls of masses m and 2m traveling in a vacuum with the initial velocities 2v and v respectively collide with each other head on as shown. So this is m, this is 2v, and then this is 2m, and then this is v. After collision, the ball of mass m rebounds to the left with the velocity v. What is the loss of kinetic energy in the collision? So after collision, what's happening? This is the mass m, and then rebounds to the left with the velocity v. So this is the velocity v, and then it's bouncing back, and then you don't know the velocity of the 2m mass, like where is it going? It is going to the left or to the right, but you can find it using conservation of momentum. Momentum before collision should be equal to momentum after collision. So momentum before collision is equal to momentum after collision. So what is the momentum before collision? Always you must remember the sign convention while dealing with the momentum, right? With the particles more than one object. So this one is having 2v in the right direction. So let's say the right direction is positive and the left direction is negative. So the momentum is mass times velocity. So the mass of the ball is m and then velocity of the ball is 2v. So 2mv is the momentum of the first object only. Okay, plus momentum of the second object should also be there, right? What is the momentum of the second object? 2m times minus v. Why is it 2m times minus v? The v is in the opposite direction. That is equal to momentum after collision should be. So this is already, it is moving to the left with velocity v. So that will be minus mv plus 2m times x. You don't know what is the x value because we are going to find the velocity, right? So 2mv minus 2mv, which is equal to 0. 2mv minus 2mv is equal to 0. That is equal to minus mv plus 2mx. So from there x is equal to x is equal to mv divided by 2m. So m cancel, v over 2. That is the velocity with which it travels. The velocity plus here, if you remember, this is the plus, which means the 2m ball moves in this direction with v over 2 velocity. Now the question is, calculate the loss of kinetic energy. So what is the kinetic energy before collision? The kinetic energy before collision is half kinetic energy of the first object. First object is m times 2v. So half mass times velocity squared, so 2v whole squared, plus half the mass of the second object is 2m, velocity is v, so half 2m times v squared, right? That is equal to the velocity of the first object after collision. So mass is m, velocity is v. So half, minus, right? This should be minus. Why? Because change in kinetic energy is minus half m v squared plus half 2m v over 2 squared, which is equal to v square over 4. So v squared over 4, right? So what is the number here? You need to calculate. So that is 4mv squared, 4v squared, 4 over 2, so 2mv squared plus 2 cancel, mv squared minus half mv squared, this 2 cancel, so half mv squared plus 1 over 4 v squared, which is 3 over 4 v squared. So that is equal to total 3v squared minus 3/4 v squared, which is equal to 4/1/4 v squared, which is equal to m. So 4/1/4 mv squared, which is equal to 9 over 4 m v squared. That is a loss in this much kinetic energy is lost during the collision. So 9 over 4 mv squared. So C is the right answer, like that. So in this question, in a nutshell, what do you need to do? You first calculate the velocity. And then calculate the change in kinetic energy or loss in kinetic energy. That's what is the logic here.